FORA.tv. The world is thinking.
I talked about the fact that you can't see planets because of the light of the star. We try and occult the light with a little mask in our telescope, but you might do it out in space. You have a telescope, and a long way away from it, perhaps 1,000,000 miles away, you have a screen, and you get the screen to hide the light from the star. So that may be something that comes in the further future. And the other technique, which is going to be in the infrared, is to use groups of telescopes, 4 in fact, operating together. Does anyone remember young slits from school? If you have 2 sources, you get bits which are dark and bits which are right. Well, if you do it backwards, you can actually put what's called a null, a bit where you do not pick up any signals because they cancel out, on something you don't want. So the idea is to null out the light from a star, which would then let you see planets nearby. NASA has a program which is called the Terrestrial Planet Finder, and here there are 4 telescopes in a line, and all the signals are brought together to one point. ESA has a mission called Darwin, where they're actually sort of in a circle, and that's where you combine the signals. And by getting it right, then in fact you can basically line things up. What actually is slightly interesting, it's, you know, Chinese walls, they're having to put up test missions to prove you can set these telescopes up at precisely the right distances and keep them there, right? However, we all know, at least those of us that know, that the military have got systems like that there already, but they're secret. And you know, that was the same problem with the Hubble. You know, the Hubble is a spy satellite just looking the other way. And they had a complete test facility to prove the optics were right. But that was secret. So the Hubble people couldn't use it, and that's why, you know, their mirror was wrong. That was stupid. In fact, we know that the spy satellites are Hubble ones because some surplus ones came on the market, and they built what's called a multiple mirror telescope, and they're exactly the same size mirrors as the Hubble. Seriously. So it's just silly that a lot of the work they're doing now has already been done, but in secret. I haven't told you any of that, by the way. Now, it's going to go to a rather lovely place. Look, as you work out from the sun, the planets go around more slowly. You're happy to accept that? If you have a satellite that's orbiting the sun, a sun-orbiting satellite, further away from the Earth, can you see it will go around more slowly? However, if you line it up with the Earth and the Sun at the right distance, can you see it's got the gravitational pull of the Sun and of the Earth? And it doesn't know they're both there. And it thinks the Sun is a bit more massive, so it goes around more quickly, and if you get it to the right distance, it goes around exactly the same speed as the Earth does. It's a lovely place, it's called L2. There are loads of satellites going there in the next 10 years. I think they'll need collision avoidance systems before long. And in fact, I'm serious about it because one of ours, called Planck, is actually going to be launched in April, we hope, and that's going to the same place. So that's where a lot of satellites will be. Now, the point is with this, if you can null out the light from a star, you can see the planets. This is a simulation. What would you see of our own solar system from a distance of about 30 light years? The sun's been got rid of. We could see Venus, the Earth, and Mars. We could not, in fact, see Mercury. It's too close. So there is a chance with one of those systems, in about 10 years maybe, of seeing relatively small planets. And just to finish up with, these missions, observing in the infrared, can do more than just tell us there's a planet there. They can analyze the spectrum of the planet's atmosphere in the infrared. Now, if you looked at the spectrum of our Earth in the infrared from some distance away with a system like Darwin, this is the spectrum you get. And it's quite bumpy. And this tells us quite a lot. First of all, there's an overall curve here with a big dip. That tells us there's water vapor in the atmosphere. This big dip here tells us there's carbon dioxide in the atmosphere. Well, we know that. Nothing tells us there's nitrogen, actually. But this is the key one. Ozone. I've said this before, I think, in another lecture. Ozone can only exist in an atmosphere if there's free oxygen. Oxygen is a highly reactive element. Unless it's replenished, it will soon disappear into oxides. So there must be something giving free oxygen if there's ozone. The only way we know of that at the moment is some form of life. So if we find ozone in the atmosphere of a planet, we might know that at least simple life exists there. And that's a more detailed view of the spectrum. Water vapor, you can tell, oxygen, ozone, bit of methane possibly, and CO2. If you look at the other planets we know of in our solar system nearby, Venus shows you bags of CO2. Mars shows you CO2. It's only the Earth that has this more exciting and interesting spectrum, and that's because we're here. So not only will we be able to detect, I hope within a few years, Earth-sized planets, we might also be able to detect if there's any simple life, or any life at all, on some of those planets.